inside of Mars, you get 27-hour days. Well, some of the crew come back stronger. Because
Really?
if you ask the astronauts what the 3 most important things in space, they're like, I want to make sure the toilet's working, I want to make sure I have food, and the exercise systems have to be up.
Hello, I'm Dr. William E. Morgan, president of Parker University, and I have a very special guest with me today, Cody Burkhart. Cody, thanks for joining us today.
Thank you so much for having me.
So can you tell us a little bit about yourself and your interest?
Sure. Background-wise, I went to school for aerospace and mechanical engineering. Started working full-time at NASA, have been doing that for about 19 years, almost 20. Focus has been on things like early career multi-mission space exploration vehicle, like a submarine on wheels. Kind of transitioned, split my life in two about 5 years into my career. Started wanting to be a professional athlete or semi-professional athlete. Ended up hurting myself, and then kind of used that coaching conversation to become my mentor. And so I call this kind of my Silicon Valley of human performance introduction. That's where I met folks like Andy Galpin and Andrew Huberman, Diane Fu, Carl Pally, all because of my mentor, Brian McKenzie. And so I kind of got to see a different side of human performance. And so kind of smashed those two worlds together, became the project manager of ARED, the Advanced Resistive Exercise Device. That's what we use on the International Space Station for the majority of our strength and conditioning work. And through that process, because I had been working with athletes, special forces operators, et cetera, I started to recognize that there were some different challenges that we weren't maturing necessarily as fast as I felt that we could or should relative to the research on the ground. So we put together a lab, started as a rogue lab. Now we're called Human Works. We like to say that we focus on the skunk works of the human vehicle. And so we do things, markerless motion capture, exosuit technologies, AI, et cetera, trying to figure out not necessarily how do I make my business move faster, but how do I take care of somebody on Mars? So how do I have a Bill in a box and a Cody in the box and a Doc in the box so that I can create that trust vector? So a lot of the internal work that I do for NASA is focused on that. On the outside, relative to trying to expand these technologies, there are some amazing technologies that come through our lab that don't work for space. And so, however, I really want those technologies for my children. And so we put together an outside conversation, a fund and a non-for-profit, in order to try and be that kind of catch tool for some of the technical hardening that comes within the government. And so throughout time, I've been trying to merge those two realms together in order to hopefully unlock some of these high performance problems and things like F1 and healthcare and industrial athletes, et cetera, and link those to what we have as far as government challenges and kind of merge that down to first principles so that we can figure out what those core technologies that we all really need to evolve. And those are the kinds of things that really interest me.
That's encouraging, because my experience in the military would be they come up with the technology, we'll work on it. No, it doesn't have military utility, so they put it on the shelf.
Right.
And it doesn't have military utility, but it can help humanity on these other ways. So you're actually capturing things that don't have utility to go to space, but they make the world a better place.
Correct. And I think that this is one of those challenges that's existed within the federal government. You usually see this kind of PE and VC line, which in our country, we're a capitalistic economy, that's our superpower, our ability to have that external capital to accelerate things. But they kind of cherry pick what they want on the edge. How do we get that maturation where they're actually saying, these are the things that we're seeing, these are the new technologies that we understand, here's where we're really wanting to invest in, and that's the kind of information that within the federal government allows us to organize policy, organize requirements, organize the technology so that we do create this kind of seamless concentric circles of value.
And as we record this, the world's going through a great disruptive period of time, so we hope this is able to continue in the future. Now, we have a real strong interest in human performance and adaptability, as you do, and as we age. And some of the things that we're interested that we see in people as they age, sarcopenia, osteopenia, osteoporosis, dementia, issues with eyes. I think people who research space travel see that those things happening quickly, and you're trying to recover those. Are there any things that you're learning in your research that we can apply to humans on Earth to prevent advancement of osteoporosis or sarcopenia?
So I'll kind of specify maybe a little bit away from that. Reason being is relative to the bone group, I would want them to answer that question, right? Some of the muscle groups to answer those from life sciences. But in particular, when we start talking about sarcopenia and the idea of muscle loss, one of the things that Andy and I had spoken about a really long time ago when I used to kind of interact with his students was, what would you do, Andy, if you had, the preparation time to get an astronaut ready? his conversation was like, let's go on a testosterone cycle, right? Like, let's build your muscle before we get into degradation. My interest, though, is to say, less than trying to prep somebody to say, I'm going to make you super muscular and then we're going to slowly filter you down to zero. We're trying to kind of bend the rule a little bit and say, I'm not only concerned about your threshold and saying, how do I get you to that next level? I want to say, how do I get you at peak performance? Because ultimately those humans are the individuals who are driving all those decisions and helping to save the mission in times of concern.
It'll be like adding a bunch of muscle in middle age, so they'll have more muscle left as it degrades over time, but you're not stopping the degradation.
No, again, for our tools, the current system is the perfect example. Some of the crew come back stronger. Because
Really?
for the first time in a very long time, they've consistently worked out 6 to 7 days a week for months, right? So consistency in that practice that we all know will inevitably build for us is something that they actually lock in. So when they're at home, all the distractions, the family, the moving around, having to go to different locations, all the training practices, etc., very disruptive. And so some of these crew members, again, gain muscle, gain strength, gain performance before they come back down. That being said, and that's a wonderful thing, when we fly them back down, basically we have everyone there within 24 hours. They're shipped back to Houston, and it's this wonderful opportunity. That's not going to be the case for Mars. So how do we make some of these systems that are the welcome party, that have matured you throughout the entire conversation? In particular to this summit, as an example, one of the individuals that I work with, Doug Goldstein, he and I showed some of the technologies that we're trying to understand. In this case, astronaut back pain is a tremendous problem. Pretty much every single astronaut that goes to space, within the first few days, sometimes within weeks, they'll experience mid to low back pain. And so our conversation is, are there tools like, in this case, dry needling with a high frequency electrocution to be able to try and reset the pennation angle on that tissue now suddenly without having access to stretching gears and all these other technologies and tools and somebody who can do handwork manipulation? Can these kinds of technologies open up, for instance, force production and tissue length, promoting healthier spine conversations and loading, right?
That's something I'm interested in. I've had a couple of astronauts as patients. And are you familiar with the diurnal effect of intervertebral disc?
Yes.
So, of course, when you're in space, you just keep the disc growing bigger and bigger and bigger. When I took care of Navy football, we would have, on game day, the football players would all have back pain. And what it is at the Naval Academy, these guys are studying to be engineers. So they're practicing football, they're studying to be engineers, they have all their military obligations. So they're getting 4 or 5 hours a night of sleep.
Right.
We take them to a hotel before the game, they get 8 or 9 hours. They're not used to that diurnal effect. Could it be that they grow and it tears the Sharpie fibers as it keeps growing and you get some bony edema in there? This is kind of geeky for me. When I spent time, I'm a diver and a bit involved in dive medicine. When I went down to Key Largo with Dr. Detroit, he spent 100 days underwater. The pressure, he got shorter. So he didn't have the diurnal effect. So it could be, have you guys considered hyperbarics on the trip to Mars?
So we've had some conversations. I'll say the first thing that really has been in existence is the penguin suit, right? So basically this thing that tries to keep you, compressed. There's also lower body loader mechanisms, so lower body negative pressure conversations as well to pull the blood flow. So to this point though, in asking requirements to, the life sciences team, the conversation is, do you need compression? Do you need load? What's the most important thing relative to your conversation? And some of those, again, I think are changing over time, especially as we see astronauts longer and longer in space. And knowing that there's different and unique changes that happen after, kind of like 6 months worth of time. That compartmentalization, I think, is also stacked onto, there's a neurological effect of gravity, right? So what you're talking about is how I'm expanding and moving all these things, but my vestibular system as well, I'm now floating all of those fluids. I don't get good clear signals. My otolith organs will respond quite well because they're still just looking for accelerations, but I don't have any visual, I don't have proprioceptive. And so some of these is not just about loading the spine, but also then working on stabilization. So one of the things that we're doing in our lab right now is creating sensory motor systems to help train that sensory motor stability system in order to allow them to, even as they're changing in their morphology, still practicing some of those stepwise functions such that when they do get to pay dirt, we don't see hopefully as many impacts to those kind of extensions within tissue. And also the ligaments themselves are becoming looser.
Well, that's right. They would. I didn't even think about that. So when I'm watching people exercise in the International Space Station, it seems very one-dimensional, but they're
There's a reason for that.
Why is that?
Vibration, isolation, and stabilization.
Is vibrating too?
So in ARID, as an example, we have two what are called VIS units, vibration, isolation, stabilization units, on each side.
Okay.
And that basically allows us to do very well like this, very well like this, very well like this, but just like your knee, really terribly like this. And so we can't do cross-rotational very well. So we have to do things like turn sideways to do side bends, etc. That's something that we, from our lab, are trying to understand how we can produce those systems, because we do realize that cross-rotational movements are more highly complex, and we don't want to get stuck in that linear style programming, which we've seen have negative impacts already here on Terra.
And also, if you're loading, you could have your trabecular patterns load up in like railroad tracks. So it's really strong for compressive loads, but they slip to the side and they break their hip.
Correct. And the interesting thing too is if you actually watch somebody work on space, especially on ARID, and you watch the video, it's a clamshell. They don't actually move, right? And so it's a very different reality of like basically pushing this thing away from you, almost like a leg press in the squat.
You invented that.
I did not invent this. My team has been supporting it for the last 12 years. It was designed by a different subset. We basically designed all the pieces to fix and repair and kind of add new features to that. But no, I can't take credit. There's many brilliant people who did that.
So somebody who's starting to face old age, how can we apply those to geriatrics?
I think this is a tremendous question. Beyond seeing how degradation happens at an accelerated rate in some of these ecosystems, I think what we also get to do is try and test new things, right? Understanding if I load a bone in this way, does that actually get the response that I'm looking for? A perfect example is when running, right? I'm a big runner, and from that standpoint, I'm a very big pose runner. And so the idea of landing midfoot, forefoot. However, in space, some of the conversations are, do we want to land on the heel bone so that we're actually damaging that heel bone and causing that osteoblastic relationship so that we don't lose density in the heel bone?
Oh,
this becomes a conversation that's really interesting to me, because I go, you've got this Achilles that's really ripping at it. And if I actually properly load my foot with that leaf spring and ride up the posterior chain, I am pulling on that bone. And so some of the questions become, what are we seeing about, should I be trying to, hard hammer some of these different bones or joints in order to get that relationship? Or should I be fixing the actual movement patterns of the individual in order to provide load in the direct, incorrect areas? Which, again, this kind of stacks on to the idea of that linear problem of being inside the machine, right? Where I'm only loading in certain times over and over again, therefore creating tensions in certain areas, laxity in other areas. So being able to understand, I think that's one critical function. I think two, the brain piece is a really big one, right? So trying to understand unobtrusive measures. How does your voice change? How do you change in clicking a button, right? Is it the speed change over time? So they can start to see early degradation moments and start to understand, are there interesting or unique technologies that I might pull down here to Earth? So as an example, if I anticipate a circadian reset, it's one of the technologies that we've been looking at. Inside of Mars, you got 27-hour days. If I'm trying to help that person be settled, can that technology be useful for helping somebody on Earth be settled? So again, thinking about geriatric conversations, as I start getting older and my sleep starts getting naturally disrupted and having those conversations, can I improve that sleep quality such that I can improve the general function throughout the day? The other thing I think that is notoriously sometimes seen as a negative thing, which is this little red line that moves across the screen. So from an astronaut standpoint, they have very specific blocks all day long, and the line moves to those blocks. And as soon as you get that block, that's the next activity you have to do. Exercise is a nice 1.5 hour free block where they have a lot more emotional and psychological connection to that. And what we've seen is, if you ask the astronauts what are the 3 most important things in space, they're like, I want to make sure the toilet's working, I want to make sure I have food, and the exercise systems have to be up. So we have to make sure that our systems can be up within 24 hours of any damage, because they're that critical to the experience. This is where I think, again, driving back to longevity, those 3 things tell you something, right? How am I taking care of my food, right? And from the restroom standpoint, again, we all want to have access to that. But then how am I taking care of my physicality? Those become the 2 primary points. The last piece I'll throw in here is sleep. Sleep is very different in space. And so as we understand technologies like light shift conversations, et cetera, can we then apply those technologies on the ground, which we've seen, right? Red light shift is something that we applied early on in space to get that melatonin shift. And now we see a lot of people using that, as a preparation for eating. So perfect example, my son's room, red lights all over. So as soon as I started seeing some of that data and seeing the resultant, we wanted to make sure that we had those red lights in every night. Because
so you prepare them to sleep by shifting to red light. So that's one of those things we can apply directly. Also, loading the bones. Loading the bones.
Exercise. If you're not exercising, it's very few things are an N of infinity. right? So if I take a bell curve of things that we might want to do, let's say it's HRV, I'm like, we're going to only pay attention to your HRV. For 1/3 of us, it's a great measure. For 1/3, it's so-so, and for 1/3, it's pretty much crud. And so for 2/3, I'm probably making a bad recommendation. So how do I start analyzing and understanding where your 1/3s are? What are the tools or the metrics that I should actually be recording on you, as opposed to just giving you a wearable and saying, go to town? And I mention this because we don't send, as an example, wearables for an astronaut. They get to choose if they want to wear a wearable themselves. We have some wearables that we send for different tests, et cetera, but not a specific requirement. And so again, the reason I say that is this watch that I'm wearing right now, I'm using it for mostly the GPS conversation and trying to figure out how my run paces were. I don't really pay attention to the heart rate because I'm using a light-based, shine technique with the LED trying to capture that blood flow. It's not very good. It's not very consistent. These are those other objectives of like, can I learn some of these things that you should be using? And
Trading one thing for the other. This is really good at my pace, but it's not really good for biomarkers.
right. So when somebody says, hey, I want to get a new sensor, I always ask, like, why do you wear it? Most people don't know the answer to that question. They wear it because they wear it. And so it's really about trying to ask those deeper level questions, which in space, we have to ask them from a survivability standpoint, but we want to ask them for a thrivability standpoint. How do we then transition that to the Earth?
So part of what we should look at is what's your goals? What's your goals in life? I want to live long. I want to be able to pick up my grandkids. And what measurements are important to you, but also to educate them to know what the important things are. But what I'm hearing is what we've learned from space research is sleep and exercise as we age are probably the biggest factors that you're trying to influence to ensure that we don't degrade on our trip to Mars.
Yeah, and again, you could throw out other pieces, right? Like I want to make sure breath work, that one's huge for me.
Really?
And that one is not something that we've necessarily put as much into practice. We do pre-breathes before an EVA, an extravehicular activity, in order to balance out the fact that you're now having a different oxygen percentage and different pressurization. But we don't necessarily have a breathwork practice. And I think, again, while that's not necessarily something that we've tested in space, the transition is the reverse direction. We've seen such success in Terra being able to, create those moments of parasympathetic opportunity, right? And a sympathetic responding tissue where we typically like to build these automatic efficient responses, and we never necessarily take the break to go, is this a good efficient response? Should I modify that response? And then also the ability of just translating yourself from a high situation to a low situation, or low situation to a high situation, and then being able to build that general oxygen CO2 balance. Those things I think are becoming more important. Again, we see them in our PLIS system, like the portable life support system, the ECLIS system, the environmental control life support system, the things that manage the CO2 and O2, but we as an individual are our own manager of CO2 and O2.
And breath work is really important to free divers as well for volume. And also the human diver response is something you can not manipulate, but you can enhance.
Absolutely. In fact, there was a time that my friends and I would hit on Airdyne bikes, then shove our face into an ice bucket of water. Yeah, exactly. It's just to get that response in order to improve for the next interval. And those are those interesting moments about my physiology, right? How do I respond to these extreme conditions to basically unlock different superpowers? And can I activate those sequences, as an example, for an astronaut or for an athlete or for myself in order to make sure that I optimize for whatever situation I'm in? Perfect example would be like, if I have a high cognitive task, I want to schedule that early on in the sortie, right? I don't want to do a large physiological movement paradigm and then try to get to that cognitive task.
And you're fatigued.
Correct. So again, these are those things I think of. It's not just about what we learn in space as much as it's about what are we learning in both of these regimes. And again, to that early point of trying to find those overlapping problems between the federal government and the outside, are those touch points worth exploring, right? Should I be diving in deeper into breath work? Should I be understanding exercise in a different way? Again, getting back to the exercise, we keep getting asked lower power, lower mass, lower volume. That's allowed us to explore things like BFR, EMS, and saying these technologies, beyond just providing load to the tissue and therefore reducing some of the other hardware we would have to have, I can also create blood flow systems. Can I move blood efficiently through the system where, again, in space, my arterial return stroke pulls the blood up. I have my leg muscles that move around and push more blood up. And so I end up getting high intracranial pressure. We have this resultant called SANS, spaceflight associated neuroocular syndrome. Those are unique challenges that also, I think, unlock some of the conversations for down here on Earth. How do I understand what happens to inflammation of the brain at a severe level, and can we learn something here? And what are we learning about inflammation of the brain down here that can translate into that conversation? So we try to take all of that, just again, like the BFR and EMS conversation, to read between the tea leaves and say, what can we do to our exercise system to make it more of a human management system, less than just training?
Well, thank you so much.
No, I'm very
Thanks for joining us today.
Yeah, thank you.
You've been listening to Cody Burkhart, and this is Parker University.